Question 1. There is a ring of 1.1 kg mass. That means the weight of the ring will be 11 newtons. 1.1 multiplied by 10. Okay. The light string is attached to the ring and the ring is pulled with a force of 13 newton. They have shown here. Alpha below the horizontal, that is the angle. Okay. Where the tan alpha is 5 over 12. Let's take care of this first. So this is a triangle which is not here, right? This is the angle alpha, and if tan alpha is 5 over 12, that means 5 is opposite, which is this, 12 is adjacent, which is this, and by Pythagorean theorem we can find the hypotenuse. 12 square equal to hypotenuse square, which is 25 plus 144 h square 169 equal to h square, so h becomes, after square rooting, 13. So why did I convert this tan alpha into a triangle and found the hypotenuse? Because I will need the components of this 13 newton, and we know the component in this direction will be 13 cos alpha, right? And now from here we can find what is cos alpha. Cos alpha will be adjacent over hypotenuse, 12 over 13. So whenever we need to evaluate this cos alpha, we will use 12 over 13. All right. Ring is in equilibrium. That is important. It is in equilibrium means nothing is moving. All right. Find the frictional component of the contact force on the ring. Basically, they're asking us what is the magnitude of frictional force. Frictional force is mu r, and that's because r is part of it. R is the normal contact force, and that's why it is called the frictional component of contact force. Frictional component force of this will be frictional force actually. So mu r. All right. So first of all, we should know that if it is in equilibrium, that means friction is this way, which is stopping this ring from moving to the left side. So this mu r frictional force has to be equal to 13 cos alpha. So it is equal to 13 cos alpha. So will be 13, and cos alpha is, we just found out, 12 over 13. 13 and 13 cancel. 12 newton is the frictional force, which is frictional component of the contact force. Okay, part 2. Find the normal component of the contact force. Normal component means this is in equilibrium. That means there should be a force upwards which will be equal to 11 newtons, right? But it is not only 11 newtons. This is 13 cos alpha component of 30 newtons. There will be a vertical component of 30 newton, which will be 13 sine alpha, right? And normal contact force, which is upwards, will be equal to these two forces. Then only this system will be in equilibrium. So they're saying normal component of the contact force, which is R, it will be equal to 11 plus 13 sine alpha. And just like we found cos alpha, let's find sine alpha, which will be opposite, which is 5 over hypotenuse 13. So we'll do it here. 11 plus 13 times 5 over 13. They cancel out. 11 plus 5. 16 newton is the normal contact force. Number 3. Given that the equilibrium of the ring is limiting, okay, limiting means it is stopping. This friction is the only one stopping it from moving. Find the coefficient of the friction between the ring and the rod. So we know that mu r, we just found out, is 12 newton in first part. So mu we need to find out, and it will be 12 over r. R also we found out, 12 over 16. So the answer will be 3, 4. So 0.75 is the coefficient of friction. Question 2. We have some coplanar forces here. Coplanar forces means they are not vertical forces. They are horizontal forces where gravity is not part of any force. So ignore gravity in this one. That's why they have not given mass of the particle anywhere. Okay, so these are drawn here on the right side. The resultant of the three forces has a magnitude of r newtons. Okay, acts at alpha degree anti-clockwise from the force 100 newtons. So in this direction it is. Okay, so find R and alpha. All right. So first for resultant, we should find what is the resultant in x direction first. X direction is the horizontal direction. This is horizontal direction. Okay. So it is 100 newtons in this direction. So let me write components of this uh, angled force, which is 250 newtons. So the x component will be in addition to the 100 newtons, 250 cos 70 degrees, and there will be a force downwards 250 sine 70 degrees. All right, we were on track to find the resultant in x direction, and now we know there are two forces, both are rightwards. 100 plus 250 cos 70 degrees. Okay, so it comes out to be 185.5 newtons. Now, resultant in y direction, we have 300 newtons upwards and 250 downwards. That means the difference of these two forces will be the resultant. So let me assume that 300 is more, which is obviously because sine 70 cannot be more than 1. So it will make 250 less than 250, and that's why 300 is a greater force. I understand. Okay, sine 70 degrees, and this is 65.08 newtons, and this is upwards, this is rightwards. Now we will draw the resultant. So resultant will be upwards is 65.08, and rightwards from its head will be 185.5 newtons, and the resultant will be from the tail of the first force to the head of the second force. This is the resultant, overall resultant. And if we want to find the magnitude of this resultant, which is the part of the question, find R and alpha, we'll use Pythagorean theorem because we know this is 90 degree. So R square equal to 65.08 square plus 185.5 square. So R square, rather we can square root both sides, and R comes out to 196.58. Those three significant figures will be 197 newtons. Now alpha is remaining. They said alpha is anti-clockwise from 100 newtons. So this is the angle. So we know this is the direction of 100 newtons. So this will also become the direction of 100 newtons. Okay, this is the direction. Why? Because the tail, from tail we find the direction of resultant, and if somehow I find this angle, I will subtract it from 90, and then I will find the angle which resultant is making with the direction of 100 newtons. So let's find this angle. Let's call it theta. So theta, let's use tan theta in this case. Tan theta will be opposite 185.5 over 65.08. So theta will be tan inverse 185.5 over 65.08, and that is, which is 70.66. So let's take 70.7, three significant figures, and alpha, which is the angle here. Let me specified. This is alpha and this is theta, and their sum is 90 degree. So alpha is 90 minus 70.7, which is 19.3 degrees. This is the angle of the resultant with 100 Newton force. Question 3. A boy runs from a point A to point C, he pauses at C. So this is A and he goes to a place C and he pauses here. Okay, and then walks back towards A. Okay, then he walks back towards A until reaches point B. So point B could be somewhere here. Okay. Okay, so he reached B. The diagram shows the graph of V against T. Vt graph is there on the right side. Okay, boy's velocity at time T. Okay, after leaving A. The boy runs and walks in the same straight line throughout. Okay, so I've drawn here two lines for simplicity, but actually he turns back on the same line. That's what they're trying to say. Find the distances AC and AB. Okay, so first phase we should interpret where is A and where is C. So this is A where he started, then he had a velocity, some velocity and stopped at C. This is C. Then he stayed at C for some time and then he turned his direction because now the velocity is negative. That means his direction is opposite. So he from stationary he had a velocity of 4 meters per second in opposite direction and then he reached here at B. This is the interpretation. All right. So if we want to find AC, the distance AC, we should find the area under the curve, this one. And there's no curve, it's a straight line. So this rectangle will find the area. So AC equal to the area of the rectangle, which is length is 10 seconds, okay, and width is 7 meters per second, so 70 meters. Now AB, so we know that this will be the distance, this rectangle will be the distance from B to C. So let's find BC and then we'll subtract from AC. So BC will be the area of the rectangle. The rectangle's area is 15 to 30. 15 is the length and width is 4. We'll take positive 4, okay, because we're finding the area. 60 meters. All right. So we know that this whole distance is 70 and this distance is 60 and they are asking what is the distance AB. So it will be AB will be 70 minus 60, which is just 10 meters. So we found both AC and AB. Number 2, sketch the graph of x against t where x meters is the boy's displacement. Okay, so let's draw it here against time. Okay, show clearly the values of t and x when the boy arrives at C, when he leaves C, and when he arrives at B. So I have already interpreted there in the first part. So first I will write 10 seconds, then 5 seconds more, 15 seconds, then we have 30 seconds. Okay, so in first 10 seconds you can see that it's a flat straight line. That means the velocity is exactly same, constant, and velocity is constant means the gradient of xt graph will be constant. That means it will be a straight tilted line till 70 meters. So let's write 70 here, and this is where he will reach in 10 seconds. So that's it. Straight line, its gradient is constant, which is 7. Can you see? 70 divided by 10 will be 7, which is the velocity. Perfect. Now he is stationary for next 5 seconds. So he will be stationary for 5 seconds till 15 seconds. He will be stationary here. All right. And then he changes the direction. Then the speed becomes minus 4 meters per second. That means the gradient of the next line will be minus 4 meters per second. But we know he will cover just 60 meters and remain 10 meters away from point C. So somewhere here he will reach. He will not reach at C exactly because C is our reference, and this will be the sea level. They're saying clearly the values of t and x we have written here 10 15, 30, 70, and this will be 6, this will be 10, right? Okay, we have done x and t values. Arriving at C, okay, arriving at C, so this is where it arrives at C. And when he arrives at B, so he arrives at B here. So we have clearly shown this on the graph. Question 4. The top of an inclined plane is at a height of 0.7 meters. So let's draw it. This is the top and it is 0.7 meters from the level of bottom. A block of 0.2 kg is released. Okay, released is the word here. Released means U is 0. It is just let go. So this is the thing and its mass is 0.2 kg. Alright. From the top of the plane and slides down 2.5 meters to the bottom. So this whole length is 2.5 meters. Find the kinetic energy. Okay. What is kinetic energy? Of the block when it reaches the bottom here. Okay. Of the plane in each of the following cases. First, the plane is smooth. That means there is only one force downwards, which is the component of the weight. What is the weight of this particular particle? It will be 2 newtons because mass is 0.2 kg. So the weight will be 10 times it, 2 newtons. So the component in this direction will be 2 sine theta. Let's say this is theta. Okay, let's find theta first. So we know that this theta we can use sine theta, right? Sine theta is opposite is 0.7 of this theta, and divide by hypotenuse, which is 2.5 meters given. So theta will be sine inverse 0.7 divided by 2.5, which is 16.3 degrees. All right. So there's no force on backward, so there's nothing, no force is stopping it. So this is the only force which is taking it forward. So let's find the acceleration of this particular particle because of that force. So MA is equal to applied force minus resistive force. M is 0.2. Acceleration we want to find out. Applied force will be 2 sine theta now, which is 2, or rather sine theta is known to us. Sine theta is 0.7 over 2.5. So let's start 0.7 over 2.5. All right. And now we have to find acceleration. So acceleration in this case will be 2 times 0.7 over 2.5 and divided by 0.2. So this and this will be 10, and 2.5 times 4 is 10, so it will be 2.8 meters per second square. Now they're asking us the kinetic energy. Kinetic energy is half mv square. So mass is known to us. If we somehow know what is the velocity here, we will find the kinetic energy. And we can use the formula here. V square equal to U square plus 2 AS. So V square we want to know, U square we know, U is 0, so U square will be 0. I'm not writing it. 2 times acceleration is known to us now, 2.8. And this is the distance it traveled. So 2 times 2.5 is 5, and 5 times 2.8 will be 14. Okay, so let's use V square. I don't want to square root anymore because I need V square here. So half times mass is 0.2 times 14. 2 is 0.1 here, and it becomes 1.4 joules. That is the kinetic energy in part 1 when the surface is smooth. Now second part. The coefficient of friction between the plane and the block is 0.115. So that changes things. So now we have 0.15 coefficient of friction. So there will be a resistive force now. So let's find that resistive force first. Okay. So that force will be force of friction, which is mu times R. Mu is given to us 0.15. R will be the y component of the 2 Newton weight. So it will be 2 cos theta. So reaction force, normal contact force will be the same, 2 cos theta. All right. So it will be 2 cos, and theta we know now, 16.3. This is what we found out, degrees. All right, so we just like in previous part we found acceleration. Let's find acceleration by this. So it will be 0.2 a again, but this time it will be 2 times 0.7 over 2.5, which is this force, which is bringing it down. But there is a resistive force this time. Earlier there was nothing after this. Now there is a resistive force, which is, let's make it 0.3. 2 times 0.15 will be 0.3 cos 16.3 degrees. So 0.2a equal to 0.273. If I put this in my calculator, I get 0.273, and that gives me acceleration equal to 0.273 over 0.2. 1.366. Okay, let's write 1.37 meters per second square, but I will use 1.366 in next calculations. Now the same thing, v square, exactly same thing we're doing now, only the acceleration has changed, so our calculations will change. So v square equal to 0 square plus 2 times acceleration is now 1.37. S is 2.5. So this comes out to be kinetic energy now. Half the m is 0.2 and v square is this whole thing. 2 times 2.5 will be 5 and times 1.37. So if I put all of this in my calculator, I get 0.683. So 3 significant figures we have to write. So earlier it was 1.4 joules, but because of the work against friction, it has reduced to 0.68 joules. In question 5, a particle P moves in straight line, okay, through the origin O. The velocity of P at time t is given by this, which is, let's say, write it here, v equal to 20t minus t cube. Okay, at time t0, the particle is at rest. Okay, when t is 0, v is 0. It has rest. And displacement from O is minus 36. So S is minus 36 meter at the same instance. Find the expression for the displacement of P from O in terms of T. So we have the expression for velocity. Let's integrate the velocity equation and we'll get the equation for displacement. So it will be 20t minus t cube dt. So the integration of velocity equation gives us displacement. Integration of 20t will be 20t square over 2 minus t4 over 4 plus c. We can cancel this. Alright, now the job is to find c, and we have been given the condition that when time is 0, s is 0. We should always look for the conditions which involve the two variables in this equation other than c. So s and t are there, so we'll take s and t from here. So minus 36 equal to 10 times 0 minus 0 to the power 4 plus c. So this is 0, this is 0, c is equal to minus 36. So our equation, if I substitute the value of c in this one, it becomes s equal to 10 t square minus t to the power 4 over 4 minus 36. This is the answer of the first part, which says find an expression for the displacement, and this is the expression they wanted. All right. Find the displacement of P from O when time is t. Okay, we know displacement equation now, so we can just substitute t equal to 4. So S at 4 is equal to 10 times 4 square minus 4 to the power 4 over 4 minus 36. 4 square is 16 times 10 is 160. 1 4 will cancel with one of the 4. So 4 cube is 64 minus 36, and this is 100. 60 meters is the displacement when time is 4 seconds. Part 3. Find the values of t for which the particle is at O, at the same position. That means the displacement is 0 at O. So we have to find the time at which he will reach at O. And since they have said values, so we can expect more than one value. Okay. So this is the equation with us. S equal to 10 t square minus t to the power 404 minus 36. And at O, displacement is 0. So S is 0. So we'll make it equal to 0. So this becomes our new equation for which we have to find time. So let's multiply the whole equation by 4. So if I multiply, we get a new equation. It will be 10, rather 40 now. 40 t square minus t to the power 4 minus 144 equal to 0. So we got rid of the denominator 4. This is the equation now. Let's rearrange it and change the sign of all of them. So t to the power 4 first, then minus 40t changes its sign, and then 144 also changes its sign. All three change sign. We can do that. Actually, we multiplied by minus 1. We could have multiplied here by minus 4. So we would get the same answer. All right. Now, you can use your calculators to find the value of t square. Let's take t square equal to m. So our equation becomes m square minus 40m plus 144 equal to 0. And now, with calculator's help, we can find what is the value of m. Let me factor this and find it myself. 4 m144. Okay. So m equal to 4 and m equal to 36. These are the two answers I got by factoring. These are the roots. But our actual problem was to find time, t square. So t square is equal to 4 and t square is equal to 36. These are the ones. So square root. So in this case, time will be plus minus 2. But we will not take the negative time because time cannot be negative. Similarly here, time will be 6. So these are the two times when this particular particle comes at O and it is changing time. That means in some way it is changing its times. Question 6. A car of mass 1200 kg travels along a horizontal straight road. Okay. The power of the car's engine is 20 kilowatt, 20,000 watt. The resistance to the car's motion is 400 newtons. So resistive force is 400 newton. Find the speed of the car at an instant when the acceleration is 0.5 meter per second square. All right. So we know that F net is mass times acceleration, which is equal to applied force minus resistive force. So what do we know in this case? Resistive force, yes, 400 Newton. Applied force, not yet, but we know that applied force is always power divided by the speed. So we know power and they're asking us the speed. So it will be 20,000 divided by speed. Okay, mass is known to us 1200. Acceleration given 0.5 meters per second square. So speed is the only one unknown here. So this becomes 600 and this minus 400 I can bring it to the left side. 400 plus 20,000 over V. So 1000 V equal to 20,000. So V becomes 20,000 divided by 1000, which will be 20 meters per second. Part 2. Show that the maximum possible speed of the car is 50 meters per second. That means every situation is still the same, only we need to find the maximum speed possible. So when maximum speed is reached, isn't it the same instant when acceleration becomes zero? There is no more acceleration. It is at the highest speed now. So acceleration is zero. In this equation, we will write acceleration equal to zero. So ma becomes zero equals to 20,000 over v minus 400. So now only 400 will come to the left side equal to 20,000 over v, and v and 400 will interchange their places just like 1000 and v did here. So v equals to 20,000 over 400, and that must be 50 meters per second. This is the maximum velocity when there is no acceleration for the system. Okay, next one. The work done by the car's engine is from A to B, when it travels from a point A to B, is 1500 kilojoules. So from A to B, work done by car's engine. So work done by applied force is 1500 joules. Okay, work done by the resistive force will be 400 joules times distance AB. Okay, so let's use the energy equation. What is the question, by the way? The question is find the time taken. Okay, so the energy equation is delta KE, difference in kinetic energy, plus delta PE is equal to work done by applied force minus work done by resistive force. Since it is a horizontal surface, that means there is no change in potential energy. Height is not gained or lost. This is zero. And also they are saying that from A to B the speed is constant. Given that the car is traveling at its maximum possible speed between A and B, so there is no change in velocity. That means there is no change in kinetic energy also. Zero. Work done by applied force 1500 kilojoules, not joules. 1000. 1, 2, 3. Okay, minus work done by the resistance is 400, and AB, let's represent this by X. Okay, so we can find X now. We'll bring 400 to the left side. 400X equal to 1500,000. Okay, and divide both sides by 400. So X comes out to be 3, 1, 2, cancel, 750 meters. That is the distance between A and B. We need to find the time. Okay, so we can find V equal to, well, we can use the other one. S equal to ut plus half at square to find time, right? S is known to us now, 3750 equal to u was 50 meters per second, maximum speed they said, time is t, and there is no acceleration. That means the rest of it will be 0. So now we can find time is 3750 over 50, which will be 75 seconds. This is the time taken from A to B. Final question number 7. A particle P1 is projected vertically upwards from a horizontal ground, okay, with a speed of 30 meters per second. Okay, 30 meters per second is u. At same instant, another particle P2 is projected. So this is P1. Another particle P2 is projected vertically upwards from the top of a tower of the height. So there is a tower. And from here it is projected upwards, right? Yeah, vertically upwards. 25 meters tower is 25 meters tall. And its initial speed is 10 meters per second. Find the time for which P1 is higher than the top of the tower. So P2 is not in picture. Just we need to know that it will go up, stop, come down. So at what times was it at the height of 25 meters? That's the question. All right. So we can use S equal to ut plus half at square to find time. S we want is 25 meters. U is 30 meters per second for P1. Time we want to know plus half. Acceleration is downwards. It is moving up. It was thrown up, but acceleration will be downwards. So minus 10 t square. This 2 and this 10 will cancel out. So yes, we can bring everything to the left side now. So this will be minus 5t square now. So it will become 5t square here. 30t will become negative, and then we have already 25 on the left side. This becomes a quadratic. Let's simplify this by dividing by 5. So t square minus 6t plus 5 equal to 0. So we can clearly see, you can use your calculator, that the times we are getting here is the factors of this will be t minus 1 and t minus 5. So t is equal to 1 second and t is equal to 5 seconds. These are the two answers. That means after 1 second it was at a height of 25 meters, then it went up, came down, and when it reached at 25 meters again, the time was 5 seconds. So these are the two times. Let's go to number 2. The velocities of the particle at the instant when the particles are at the same height. Okay, this will be, we'll need a thought on this. So they are saying velocities and same height. So let's take the hint from same height. So height, let's use the same formula again, this one. So this time let's say h is the height when they are at the same height. H equal to, for the P1 first, P1 30t, again we want to know the time, and plus half times minus 10 t square. Okay, so it becomes what? 30 t minus 5 t square. Okay, that's the height of P1. But P2 has a lead of 25 meters. So let's call it H2, its height above 25 meters, then we'll add 25 meters to it, okay? So H2 will be 10t minus 5t square, right? That's the H2. But if I want to compare this with this, I will have to use plus 25 on this side and plus 25 on this side. Now this becomes H because it was already at a height of 25 meters, right? And now we can equate this H and this H. So it will be what? 30 t minus 5t square equal to 10t minus 5t square plus 25. 5t square is in both sides, negative both, so we can cancel them out. Alright, this 10t when it comes to the left side will be 30t minus 10t equal to 25. 20t equal to 25, so t is 25 divided by 20, 1.25 seconds. So since both of them were thrown at the same time, 1.25 seconds after they were thrown, they were at the same height. Okay, but the question was find the velocities of those particles. Now it becomes easy to find velocities. So let's write velocity of particle 1 will be u plus 80. U was 30 plus rather minus 10 is the acceleration. Time is now 1.25. So 30 minus 12.5, 17.5. This is the speed of particle 1. Similarly, velocity of particle 2 will be u. U is 10 plus minus 10 again times t is 1.25. So it becomes 10 minus 12.5, which is minus 2.5. It means it is falling downwards. This is still going upwards by 17.5 meters per second, but the particle 2 is going downwards by 2.5 meters per second. Alright, we found the velocities. What is the third part? The time for which P1 is higher than P2 and is moving upwards. Okay, so that is a little tricky. First, let's find when H2 is greater than, which one are the same? P1 is higher than P2 and is moving upwards. Okay. So H1 is greater than H2. And second condition is that H1 should be going up. So we can take hint from the question we did earlier. We saw that P1 is going down. So P2 is going down. And P1 is going up. Yeah. Obviously, after 1.2 seconds, after 1.25 seconds, P1, H1 will be greater than H2. It will be at greater height, right? And it is going up. That means we have to just find at what time it stops. And then it will start coming down, which will not be the second condition. They want it to be above, higher than P2 and moving upwards. So somehow, if we find when it stops, that is our second limit of the time. So V equal to U plus 80, right? So V, when it will go and stop up there, its velocity will be 0. For P1 I'm talking about. Equal to U was 30 for it, and we know that acceleration is minus 10t. So 10t equal to 30, where t is 3 seconds. So our answer is 1.25 and 3 seconds is the time when it is moving up and it is above the height of P2. There is no equal sign because at 1.25 seconds they are at equal height, and at 3 seconds it is not moving up. It has stopped. So no equal sign.